Y'all showed up, so who am I to disappoint you? So welcome back to our last class together. Would you like an update on how your class evals are doing? Think you're going to be excited. One more. Question? Screen share? Yep.
Yes, please.
Got it. You'd think I'd remember. You would be mistaken. There. 10 out of 13. I need one more. So nag your friends. And what is the deal that I offered if 11 out of 13 of you complete a university course evaluation by this Saturday night? 1 point extra credit for everybody, including the 2 people who didn't do it, by the way. And you also should have gotten a Qualtrics survey invitation to complete a separate course evaluation that is much more specific and qualitative in nature. And that is going to be open until the end of finals week. Each person who does that gets another point extra credit. So we are getting there. And you're beating the other class too, so you should feel good about that. If anyone has a competitive spirit. In terms of what is left, there's not much. So just a reminder that if you haven't submitted your first draft of homework 5, individual data analyses, please try to do that by Friday so that I can guarantee your feedback in time for a revision. If not, I will try to grade it as soon as I get it, but I can't guarantee I'll have enough time to turn it around. So you can submit it at any point until the end of the semester. Homework 6 is due at the end of finals week by 5 o'clock, as well as any other outstanding work or revisions. So next week, I have office hours, the TAs do not. And my Monday office hours, as a reminder, moved from 1:30 to 2:30 instead. But then Tuesday, Thursday is 12:30 to 3:30 when I would normally be teaching, and Wednesday I'm keeping it at 3 to 4, and then Friday I don't have any planned. I will be on email as frequently as usual to try to get you help if you need it. Otherwise, get your stuff done, and I'll turn in your grades. How's that sound? Sounds like a plan, right? The end of the semester is a special, special time when it's like all the to-do lists are just zeroed out for something. It's beautiful. Doesn't mean that you don't have anything to do. It just means that the time-sensitive to-do pile that is coursework is over with. And I feel the same, by the way. It's like the constant, like, what am I doing? What's happening? What do I need to get done? By what day? Like that thing, the summer doesn't have that. So there's a lot less of that, which is nice. Yeah. So no homework questions then, homework 6? All right. If you change your mind, let me know. We can finish talking about path models though. We'll see how much of the stuff we get through. If not, you got the resources for the future. That's the plan. So this example is what we were working through last time. This is a real published example. We have 1 predictor, 4 mediators, and 1 outcome in this example. Not shown in the picture are correlations among the residuals of the 4 middle boxes. So every single box has a direct relationship of some kind, whether it is a directed arrow or a 2-headed arrow. And just as a review, what do the directed arrows mean? What do those correspond to in a model? Directed arrows. I can think of 4 different words that all mean the same thing. One starts with an S?
Slope.
Slope, yeah. I would also go with path. Path coefficients is what slopes are called in this context.
And edges.
Edges, yeah, nice one. The DAG representation, and don't ask me to say what that stands for again, I'm not going to get it right. And direct effects also in this context. So all of those terms are used more or less interchangeably. We had went through Stata code, Lavon code, and M+ code. There's also SAS code in the online materials for how to fit this analysis as a single group model, meaning the entire sample pooled together. Any of that you want to go back over? in terms of what we covered last time for review? This is the example that I'm pulling from for your last homework. So, motivation to make sure you're able to understand what's happening and apply it to your own problem. No? Feeling good with this? A few nods, mostly ambivalent. It's that point. I understand. Let's hit a few highlights. Look at how wonderful my model fits. It's so wonderful. In the original draft of this manuscript, I didn't report fit. And reviewer 3 is like, you need to report fit. What was my response? Ordinarily, I would agree. In this case, I do not agree. Here's your clue. The log likelihood from the HO is the same as the log likelihood from the H1. What is that telling me? Same model, yeah. Can you think of another vocabulary word that means you spent all the parameters you possibly could? Starts with a J. Yep, say it. Justified, just identified. I like it. Put it together, right? It's portmanteau. I'm justified, man. Yes, just identified, meaning it has to fit perfectly. Has to. There is no room to be wrong, because every pair of variables in this model has a connection of some kind, either a slope, making it a predictor to an outcome, or a two-headed arrow, which is what again? What are two-headed arrows? Covariances, yeah. And they, in code, they are widths for M+. They are single squiggles, I think, in Lavon. Does that sound right? I gotta look back at my own Lavon code. That one I don't have at the top of my head as much. Yep. Double squiggles. Covariances and variances are double squiggles in Lavon. Single squiggles are slopes. So if it's the same variable on either side of the squiggle, then it's a variance. If it's two different variables on either side of the squiggle, like this one, it's a covariance. And what are the things in parentheses doing here? Do you remember these, what they're for? They're in parentheses in the M+ code as well.
They're labels?
They're labels. And do you have to have them? You do not in this model. I labeled everything as a way of helping you understand what it all means, but I also did it so that I could compute indirect effects. Do you remember these? Indirect effects? The idea of, let me go back to a little bit of that. This slide I want to do real quick. An indirect effect is the literal multiplication of the slope from a predictor to a mediator times the slope of the mediator to the outcome. The logic of asking whether that product slope is significant is the answer to the question, is the relationship between the predictor and the outcome different after I control for the mediator? If A times B is significant, then the relationship from X to Y differs after controlling for M. So indirect effects. So that would mean, like, conceptually, if this indirect effect is significant, there's another reason why X and Y are related. It's because of their joint connection to M. So full mediation would render X to Y non-significant. Traditionally, partial mediation would just change it to be usually less strong of an effect. But realistically, any difference is good. This test just says C differs from C prime. That's it. Could be more, could be less, could be up, could be down. So I have 4, this is the Lavon code here, indirect effects that I am computing. So X2M1 is the label that goes with this relationship right here of mindfulness as the predictor X, predicting the first mediator. Then M1 to Y is the label that goes with the first mediator predicting the Y outcome. And note, these are not squiggles. This is the Kevin from Just Alone face. See, the internet's missing that gag. Question, Nikki?
Yes, so it's helpful. R is obviously not my base program, so it's more of a clarification question. So you don't need the labels, but I'm assuming you need the asterisks in front of your variables.
The asterisks you don't need if you don't have the label. Like it
Okay.
attaches it.
Great.
I believe that if memory serves, and someone correct me, maybe Vladimir if you know better, I believe you can also put start values in here. Is that right? Instead of labels? Maybe?
I don't know.
You don't know?
Tried.
Okay, I think so, but I could be wrong on that. But yeah, otherwise this whole thing would be removed if you don't have the label.
Yeah, are there other things? A student reached out and asked for help, and I am not quite finding what the issue is, so I'm gonna email you and Vladimir, but are there other like syntax things that as you were building this, you were like, this is a tricky thing to pay attention to?
I would say the plus signs. So if you forget a plus sign and you just have two things in a row, it won't know what to do. But it also makes it look like what you're asking it to do is add this stuff together, and that is not what's happening. It's just like the next one.
So in the residual covariances, I guess that's where I'm confused about the plus signs.
Yeah, they're not literal plus signs. They are just ways of stacking more than one thing to correlate with the thing on the left-hand side.
Oh, okay, gotcha.
Yeah, it's dumb and confusing. And wait till you get to factor analysis, because when you put the factor loadings in, it looks like you add them together too, and that is absolutely not what is not happening. So yeah, come on, Levon, what are you doing? But they had to work within the constraints of how functions work in R. I think that's the issue. So like the equal sign is already used to say what the argument to a function is, like right here. Like each of these is an argument, and so it's telling it like, what do you want to go here? This is what the data set is, this is what the model is. So they have to like work around the fact that you can't just have an equal sign. So they're like, squiggle, squiggle it is. How do you make a squiggle better? You make two of them. There is a, can I tell a joke real quick? I feel like the room could use a joke. Okay, two jokes. One of them is clean, one of them's not clean. What do you call an elephant and a rhinoceros put together? Elephino. Okay, second joke. This is a quote from Dennis Miller. He's a comedian I used to pay attention to in the 90s. He's since gone a little bit crazy and I don't really pay attention anymore. But he had a joke about shopping for suits at Kmart. So Kmart is like worse than Walmart in terms of like the higher order of department stores. And he used to talk about the 2-for-1 sale. And in his joke, he would be like, two of shit is shit, folks. They really want to screw you, they'll give you 3. So that's what I think of. 2 of shit is shit. It's sort of like times 0, right? What's a million times 0? 0. That idea. Anywho, 2 squiggles. Or colon equal if you're defining a new parameter. Elephino. All right, other coding questions. Stata people, are you feeling okay with your coding? Anything you want to go over? No? Good? Okay. Then in the output, things are relatively well labeled in Levon. So regressions gives you all of your predictive relationships, which the labels you added are right here, which I find tremendously helpful. The standardized solution, by the way, is out here. So for instance, in your homework, there are several questions asking about residual correlations. Which column is that? If I ask for something like a standardized slope or a residual correlation, where would I find that information? Let's do forced choice alternatives. Unstandardized solution or standardized solution? If I want standardized slopes and correlations, yeah, then it's like, okay, where is that? In Stata, it's a whole separate command. So this part, SEM standardize, spits out the whole model in standardized form. In Lavaan, they tack it on to the last column of the unstandardized solution. So you want this column. So your residual correlations, for instance, would be here. Under the covariances section, the estimates themselves are covariances. They get converted to correlations in the standardized solution. And in M+, they are a separate piece of output that I requested with this command, stdyx. That does not mean sexually transmitted diseases from Y to X. That means standardized with respect to both X and Y. There's other alternatives. And in M+, model results, which show up first after your fit, are the unstandardized solution. The standardized solution then follows that. So you can find that in your output after these tables are over with. Total direct and indirect effects in each separate indirect effect are new parameters in M+. They will also be listed as new parameters in Lavaan. Defined parameters is what they're called. Same idea. Okay. We started talking about the idea of moderated mediation at the end of class. So how would I ask whether these relationships differ between two groups of people? As an example, in this case, it's people who identify as men versus women. The trick is to fit the path model for each group separately but simultaneously. Then you get to control which paths get to be the same across your groups and which paths get to be different. In Stata, the first model that I'm going to fit is letting everything differ across groups. So just a whole separate model for men versus women. That is accomplished with this one line of code. And yes, it is a weird color of blue. I don't know why. But I try to recreate it faithfully. So I identify the column in my data set that divides my people into groups. And then there are choices for default specifications. G invariant none means full non-invariance. And if you're like, what? Means let them be different. This is a structural equation modeling term, testing invariance of your factor solution, whether things work the same across groups. So this just means let it all be different. That makes it super easy. Not so easy is testing differences in indirect effects across people. So what I had to do is compute each one and then compute the difference. So for instance, this is the indirect effect in 0BN, meaning the 0 group for my binary grouping variable. Here's the one for the 1 group. And then here is the difference. So the minus sign out here is doing the literal subtraction. So I'm asking it to do a Wald test that compares my indirect effects. In R, if you want to do this, you're going to do a lot of typing. I don't know of a way around this. Not saying it's not possible, saying I don't know. So what I had to do is every single place where I had put a label, I now have 2 labels. So I have M xint and W xint, meaning I'm asking for the intercept for mindfulness, but I'd like a separate version for the M group and the W group. So I did that for every single parameter, plus of course the C thing that allows it to combine. Combine, concatenate, what's C stand for?
I think it's the last one.
Concatenate?
I think so.
Yeah, that makes me sound like a real programmer that I know that word, doesn't it? It's fancy. Concatenate. If I know. So here's the indirect effects for each of the groups here. Here's the totals, and then I got into the differences. So a lot of coding to get all of the differences across the things that I'm interested in. The difference in the call to Lavon is a new option called group, where I tell it what column in my data set separates the two groups. And I believe it just applies the first label to the first group, like numerically in the variable, and then the second label to the second one. Question?
A quick one, Lisa. So, with respect to the labels that you are using at the beginning of the syntax, the first M, that should be for males?
Yes.
For men?
Yes.
Okay.
Yeah, that's my labeling convention, is I put the M at the front for the parameter and then the W at the front for the other group.
Okay.
Yep, you can do whatever you want. I do know that they get truncated at some point, and I didn't want the M's and W's to get truncated, so I put them first.
Okay. And, sorry, but
Yeah.
in the group variable, the first label we have is M or W?
It should be M, I believe.
Oh, okay.
Yep, let me double check that. Yep, so this is how I know that. I named it that way. When I name binary variables, I usually have like this versus this, or whatever it is, and then who the 0 is, and then who the 1 is. That's how my naming conventions work.
So, the model is like organizing the first set of labels based on the first label in the grouping variable.
Correct. The model is organizing the labels to go with the first group in the grouping variable.
Awesome. Thank you.
And if I had 3 groups, I'd need 3 labels. I'm not sure what the upper limit is on the number of groups, but it becomes more tedious the more you have, I would imagine. All right, so I let, in each of these analyses, every parameter differ between groups. Is my model still just identified? What do we think? Every group gets its own of everything. I say yes. Here's proof. It's perfect. Has to be. So now how do we interpret these things? First off, we have group 1 with a 0 in there, meaning the first group, which is tied to the number 0 in the data. That's for men. So this is the male model, all of the parameters, followed by the women version, all the parameters. Then we get into the newly defined parameters. So these are group-specific indirects right here. It looks like we have a significant indirect effect within the men for the first one. Within, let's see, not for the women though. So there's one difference. So it looks like the indirect effect is much larger for the men than the women if I'm just going with these numerically. I have a significance test of that down here. I think, is that it? That look right? I'd have to see. Yeah, differences in direct, oh, these are differences in direct effects. I'm not far enough, I think. This one, there we go. I'm like, I know that these two numbers do not, there's not 0.5 that's different between them. I'm not great at math, but I know that. So it's these two correspond with that one as the difference. So there is a stronger indirect effect of the first mediator in the man group than the woman group in this example. And that was the only one that was different, and that's the story. Differences in direct effects, these are the X to mediator paths and the M to Y paths. And it looks like we have some differences there as well. So we can talk about all of those. Here's what it looks like in M+. We tell it in the variable section that we have a grouping variable. And then we have the same system of labels. However, we have two distinct models. So we still have the blue model. This one is going to be specifically for the reference group, whoever is first in the grouping variable, which is men. Then we have a separate model statement for the alternative group, which is women in this case. And so because I have different labels on everything, across these two models, that means M plus is going to estimate separate parameters for each group. And then I did all the math to show the indirect effects, differences in direct effects, and differences in indirect effects. A lot of typing, unfortunately. So right now what we have obviously in front of us, meaning that you can see straight away, is here's the male model solution. Here's the woman version. Is this a moderation model? Is this related to the idea of these things interacting with gender? It's not obvious, but it is. So if I wanted to ask, is there a main effect of gender on, say, my outcome, warmth? How would that show up in a path model context? Like if you think of a regression model, right? Like y equals, let's say we put gender in as a predictor. That would give it a main effect, so to speak. How does that translate into this path model context, do you think? This one I may call on the TAs for. I'll leave T alone this time. I've already bugged you enough this week. What do you think, Vladimir?
Yeah, that's a good question.
Mm-hmm.
I think that given that we are looking at interactions, we should try to see if the differences for the effects between groups are different or not.
Mm-hmm. So if I wanted an interaction of gender with mindfulness in predicting warmth, for instance, this is the simple slope for one group, 0.2, whatever. The simple slope for the other group is right here. So we would normally have an interaction term that tells us how different one slope is from the other as part of the model. Instead, what we have is one slope, and the interaction term functionally is the difference between those two. Interaction terms tell you if slopes differ from each other. We got the slopes, we just got to find the difference. That is an interaction term. What about a main effect of gender? If I were interested in that question, what should I look at? This one's tricky. And if your answer is L if I know, that's fine. So we call that a callback. It's actually on the intercepts. If the intercepts differ from each other, that's a main effect of gender on that variable.
Can you say more about that?
I can. So in a typical regression model, let's just go back, doesn't matter what kind, like y equals intercept plus a slope times gender. So the intercept would be for men. The slope that goes with gender would raise the intercept by that much for women. Raise the predicted outcome. You can think of an intercept as a predicted outcome. So the difference between these intercepts and those of the alternative group, those are your main effects of gender. So it is the same thing. You're just parameterizing your model differently. In an interaction model, you get all the stuff for the reference group, and all the interaction terms tell you how different it is for the other group. And then you add the main effects and the interactions together, and you get what it is for the other group. That's what you guys did all semester in terms of getting simple slopes and simple slope differences. This is a different way of doing it. What is it for this group, what is it for this group is what you get directly. The difference between the two, which is the implied interaction, you can ask for indirectly through these additional constraints. One last thing is here's a way to do it that is less quick but potentially better in some rare circumstances, is to go through and constrain things equal one by one. So in Stata, for instance, if I were interested in testing whether X to the mediators differs between groups, I could set it up like this, where I have a 0 model, that's for the group coded 0 in my grouping variable, and a 1 model. That allows these terms to differ from each other. Likewise, actually no, this one right here means make that one the same and let the rest of them differ. In R, giving a parameter only one label instead of two makes them the same across the groups. It's called an invariance constraint. Nikki says, the one time we care about whether the intercept is significant. Yeah, not quite, because the intercept is per group. We want the intercept difference to be significant. And then M plus is the same. If you give the same label to the same parameter across two different groups, you're forcing it to be the same. So then the model would be over-identified by 1 degree of freedom, and then the chi-square test of model fit is the test as to whether that constraint is okay. So in the published paper, I did it this way, because I wasn't sure whether you could just ask for differences in indirect effects, and I wanted to cover my bases. And that's that. So if you have a grouping variable, this way of testing moderation of a path model can be direct and useful. If you have a continuous moderator, though, that's when you would put it in a box in the model and let it predict stuff instead. All right. Questions on any of that? Can I show you another one? Like a generalized path model? What is this? I tell you, there's only one model in this whole handout. It's only 5 pages. Quite doable. So for those of you who were in the SEM class, this is the follow-up story to the example I just gave. These were my dissertation data in which I looked at prediction of driving impairment in a driving simulator in older adults as a function of their age, visual ability, attentional ability, and processing speed. I found that vision and attention uniquely predicted driving impairment, and I was curious as to what would happen to these people eventually based on their performance. So 5 years after my dissertation was finished and I graduated, we had the research assistants who work on the study call people up and say, hey, do you remember that thing you did at the Med Center 5 years ago? Have you hit anything with your car since then by chance? Are you still driving? And had a little survey for them. And we were able to track down 114 of the 152 people. A lot of them had died or had moved into assisted living where they were no longer able to answer questions or otherwise participate in research. And we asked them if they had gotten into an accident, and I coded this as at least partially at fault based on their description of what happened. Or they received a speeding ticket. So 14 people had an accident and 14 people had a ticket. So whether or not you were in an accident and whether or not you had a speeding ticket, what does that sound like to you? I'm predicting an outcome where the choices are whether or not. What kind of outcome is that? Binary. Binary. What kind of model would I need for a binary outcome? What was Unit 2 in this class? Yeah, what did you learn in February? Let's ask it that way. What link function do we use for binary? 2 most common. Yep, logit or its cousin, probit. Yeah. And what if this was a count of the number of accidents? Then what would I need? Say it again. The first one you said? Log. Yeah. So those are all link functions that are built into M+. It does have also all of the count distributions. So it has Poisson negative binomial and 0 inflated versions of those and 0 truncated versions of those and Hurdle versions of those. It also has a multinomial and Bernoulli. It does not have anything in the binomial family, though. So all of the things that you learned about how to predict a binary outcome one at a time apply in the path models, with a few caveats. So I'm showing this only in M+, because I'm using full information maximum likelihood to estimate the model. Stata's GSIM does not quite work the same way in terms of how it addresses missing data, so I'm not showing it in that. But here are the correlations in the original study, and I am using factor scores, by the way, for the latent variables that I had in my original study, because I'm down to 114 people fitting a generalized model, and I was worried about it blowing up. Here is the end result. And I gotta tell you, of all the pictures I've ever made in a PowerPoint, I'm one of the most proud of this one. This took me like 3 years to build this picture. But we've got the predictors in the original study. So gender, age, visual impairment, speed, and then 3 different measures of attention are all predicting impairment in a driving simulator. And this outcome, by the way, has, I think, 17 people did not have scores on it because they got motion sick while they were doing the task. And I let them quit. I get motion sickness a lot in cars, so I understand. Although some of them really thought, like they felt bad about it, about quitting. There was one gentleman in particular who insisted on finishing the task with a trash can in his lap in case he threw up. Because he's like, I used to fly fighter jets in World War II, I can do this. No judgment here, sir. I can't play Mario Kart without throwing up. So, you know, I understand. We're all wired differently. So this was part of the original study. Reported limited driving was a follow-up set of questions that I asked about how much they don't drive anymore, because if you stop driving, odds are good you're not getting into a wreck. And odds are good. See, that was a pun. Because, you know, logits, odds. I'm trying here. Then we have accident type and speeding ticket type. And here are all of the paths to that, and their standard errors in parentheses, and the ones that were significant have double stars on them. So there are very few things that are significant, but the one that I was most interested in was this one right here. Performance in the driving simulator did predict who was going to get into an accident 5 years later. It was this really artificial task that looked like it was made from an Atari game, but it was useful. And this one correlation drove me to write this paper. One correlation. Like, you can do that? Here's the trick. Do you see my citation? It's Psych and Aging. It's a very good APA journal. Look how many pages it is. This is called a brief report, folks. Most journals have this format where you can write a really short paper based on a very limited set of findings and get it published. And I swear this was the easiest review process I ever had. The manuscript was like 10 pages. So I would encourage you, if you have little findings that you think are something, but they're not enough to make a paper out of, make a brief report. Because you know what? When you're indexing how many publications you have on your CV, no one's looking at the page numbers. They look the same. They count the same, okay? So me and my brief report out of one correlation. That one. So reviewer 3 wanted to argue with me about whether the arrows should go this way from my predictors to this outcome. And given this story, I knew that I had a good justification for why the arrows go this way. Do you know what it is? What is it? You're smiling. Time. These 2 boxes were collected 5 years later. So I'm pretty sure the future can't cause the past. So, predicting in the right order. Now, do you see this blue thing right here? That wasn't in the paper. I mistakenly described the model as just identified. I was wrong. Add it to the list of things in print with my name on them that I now know are wrong. It's a growing list. The reason is because these 2 outcomes are binary. They don't have residual variances. In Logit land, what's the residual variance of a binary outcome? 3.29. What's the residual variance of a probit outcome? 1. So if you don't have an estimated residual variance, you can't have an estimated covariance either in full information maximum likelihood, which is what this is. So I tried to put it in, and M+ is like, you can't do that. I'm like, I guess I can't do that. All right, who am I to argue? Well, lo and behold, future Lisa discovered, hey, you know what? I can put this thing in here. We talked about this for about 5 seconds one day, so if it doesn't look familiar, that's fine. What this is a latent factor. The same kind of latent factor that you would put into a structural equation model or a multi-level model. It's called a random intercept because the slopes from this latent factor to these boxes are both fixed to 1. What this does is introduce an extra relationship between these two outcomes whose variance is captured right here by the latent factor. Now it's just identified because now I have a relationship directly across every single pair of variables. I did not have it before. So if I were to repeat this study, I would throw that in. So here is what the code looks like to do this. For binary and ordinal outcomes in M+, there is a new option called categorical that it then understands that it is trying to fit either a binary regression model predicting that outcome or ordinal. It figures out how many categories you have, and then it figures out how many submodels it needs accordingly. I'm using Monte Carlo integration rather than quadrature, given the latent variable and 2 length functions in a very small sample. 2 of the outcomes get intercepts, the 2 middle boxes here, this one and that one. The binary outcomes get, here's a vocabulary word from February as well, thresholds. Thresholds versus intercepts, do you remember that? Vaguely? Vaguely. Thresholds tell you the logit of the probability of the lower category in your submodel, conditional on all of your predictors being 0. And I think it's hilarious, by the way, that in M+ they use $signs to notate this. Just think of it this way. If you learn this shit, someone will pay you so that they don't have to. They will. Particularly in psychometric models. IRT stuff uses thresholds. You can make a lot of money doing psychometrics. Then all of the regressions, the magic word on. So each of these is a Y on all of my predictors. So driving impairment, limiting driving, and then the 2 binary outcomes. The continuous outcomes get estimated residual variances. And then here is the new thing. By defines a latent factor. It's defining my random intercept, which is what I'm calling it here. Loading's fixed to 1, and estimating the variance of it. So this is how you put in a covariance between 2 variables if the 2 variables are binary. It's a trick. It's an indirect way of allowing dependency between these 2 outcomes, correlation. Not that I cared about it in the original paper, but I wanted to show you what it would look like to do an indirect effect in one of these models. I am using the labels at the end of each of these statements. So sim 1 through 7 is the name of the path from each of these predictors to the simulation outcome, simulated driving outcome, I should say. Lim 1 to 8 is the name of all of these things on that. Accident 1 to 9 is all of these things predicting that, and then speeding. So I picked 2 of them, Sim 7 and Act 8, which is one of the measures of attention going through the simulator outcome to the accidents. So I'm asking, is the effect of attention on eventual accidents mediated by their performance in the driving simulator? Does the effect of attention on the eventual accidents differ after controlling for performance in the simulator? Okay, how are we doing? Hanging in there? Barely. I hear you. I have no illusions about how you feel right now, but you're in front of me, and I'm contractually obligated to talk to you. For those of you who are interested in pursuing workshops, I've spoken to folks about that. Can you imagine what it would be like to sit in front of me for 8 hours a day for 5 days in a whole week? I used to teach a lot of workshops in the summertime. That's how I got myself out of student loan debt, quite frankly. Yeah, no joke. At around 2 o'clock in the afternoon every day, people are done. Like, I've never seen more done faces of the ones who I could see their faces and they weren't like hiding behind their computer monitors. But it's like, nope, you paid for this content and they paid me to deliver it, so I'm just going to keep talking at you. And that's what it feels like for all of us. So yeah, workshops are not great for learning for the reasons that you are all experiencing right now. The limits of human cognition. Let me give you something that might reorient you to why you should care. Homework question. So how well do you think this model fits? If it's just identified, it should fit perfectly, right? Well, let's find out. I got 40 parameters I estimated. Here's my log likelihood for me. I'm the hoe. Always remember that. Wait, where'd the rest of them go? All I have is AIC and BIC because I have my log likelihood. Smaller is better for AIC and BIC. Bigger is better for log likelihood, but I don't have anything else. I don't have RMSEA, I don't have CFI, I don't have any of the other acronyms that we've been looking at. They're gone. The reason they're gone is because there's no H1 model to come back to. These variable relationships cannot be described by a single covariance matrix. The continuous ones can, but how the binary ones relate to everything else would actually have to be done through contingency tables of all possible response patterns. So there's no ready, easy summary of what these data should look like to be as tall as possible that we can come back to. In other words, model fit is not evaluated in the usual way. Saying that for the YouTube. So based on this, I had no idea of knowing whether my model fit right or not. I thought it was just identified. I was wrong, but now it is after I fixed it by putting in this thing. The other part of this that gets a little bit tricky is that some of these slopes are regular slopes and some of them are predicting link things. So driving performance in the simulator is being treated as a conditionally normal outcome. That means all of these slopes are just regular regression slopes. So sex, I forget who's who in this, the one group is higher in the driving simulator performance by 0.13. For every year older you are, your predicted outcome goes down by that much. Like these are just regular regression slopes. Same is true by how much you limited driving. We're treating that as a continuous variable. But then these ones, predicting whether or not you had an accident and whether or not you had a speeding ticket. What metric are these slopes going to be in if they're predicting something binary? Logits, yeah. So for the one group, the logit of having an accident is lower by 0.7. The logit of having an accident is higher per year by 0.06. These are all logits. Likewise, predicting whether or not someone had a speeding ticket, logits. In terms of the indirect effect, it's half and half. What is it called? This one. So the path from the X to the M is a regular path. The path from the M to the Y is in logits. So it's a weird indirect effect in that it's two different metrics at the same time, but it's okay. And I have marked in these results which ones changed relative to the original publication after properly controlling for the correlation between accidents and, speeding tickets. So that variance of that random intercept is what allows those two things to be related to each other. And if you're like, what the hell does that mean? Come to the longitudinal class in the fall and I'll tell you. We'll talk a whole lot about random intercepts and random slopes. And then come to the advanced longitudinal class to put it back into SEM. So, right, T? Yeah, she suffered through that last year, right, Vladimir? Right, Nikki? Yeah, see, they live to tell about it and they're still here. It's going to be okay. And then look what M plus gives us, because it knows odds ratios, effect sizes, but only for the binary ones, because otherwise you don't need them. Here is the stata code that corresponds to the same thing, but the results don't match because of the way it addresses missing data, by the way. So stata GSEM, I think the G stands for generalized. This is how you do models that need link functions and/or have a multi-level component to them. So it tells you how many people contribute to each equation, and then it just fits the model in this sort of use all the possible data fashion without trying to recreate the parameters that would have been there under complete data. And there's the stata results for that. And the indirect effects, and all the things, and all the things. So please see the original manuscript for the results section. See, even I was like, yeah, I'm done. But with the following addition of trying to describe what the random intercept variance is trying to do. All right. Let's see. Yeah, I don't know. I got a lot of stuff in here, but I'm not feeling it. If I'm being honest with you. I've got resources for the future. So if you need to learn more about mediation or mediation with not normal outcomes, here's some links. So where it gets tricky is in the path models. Let's go back up to the picture for a second. Like if this box right here were binary, let's say it's whether or not you have this characteristic in the middle as a mediator. That gets weird because from this side, X to the mediator, that's in logits. But then this over here, it's not a logit, it's a demicode. It's just a binary predictor. So it's being treated in two different ways within the same analysis. So there's ways around that that involve something called limited information estimation, in which it becomes a probit sort of pretend continuous variable. That's what these, these links are talking about. It's even harder if you have something like a nominal variable in the middle. Then you have more than one submodel at the same time that all of that's happening. But here's some resources, excuse me, for that. And here's what all GSEM can do in terms of different link functions and choices to put in path models or structural equation models. And here's a little bit about limited information estimation instead. You'll hear more about that in the SEM class, so I have a few slides on that for your edification. And that's about it. Vladimir, do you want to talk about your thing, or do you think we should let them go early?
Yeah, I think so.
Yeah, I think so, to which?
You can go home, I think.
He's like, I don't want to be the bad guy. Can I open it and show
Yeah,
them?
of course, yeah.
Okay, so last year Vladimir made an example that I think we probably didn't have time to go over either, if memory serves, but he wanted to do it anyway. Okay, it doesn't even want to open. Yeah, I know, words like, no, you said they were done. It's thinking about it. It's an example where the end variable in a path model is nominal. Remember nominal? Unordered categories? Question? Comment?
I have one disclaimer.
Yes.
Because I was
There it
reading
is.
the file, and at some point I said that we dropped one of the school variables because
Get to the picture.
we didn't want to deal with the problem of nested data.
Oh, yeah. Here's
So
his picture.
we dropped the school variable. However, as you can imagine, all of those scores for GPA, which is name or ranking or math and language scores, I realized that even if we drop the school variable, those things can be nested because students belong to same schools.
So these are clustered data, and he ignored the clustering because he hadn't had that class yet. And now he knows that it should be a multi-level path model, and you're all like, oh my God, stop talking right now.
That's my
So,
experiment.
yeah, where did this picture come from?
That's a GSM.
GSEM made this?
Yes.
Okay, I thought this looked like a convention of some kind. So yes, this is an outcome where there's 3 different options, and these are mediators, and these are predictors, and he's got a whole set of results and indirect effects and all the things and words to describe it all. So thank you for making this resource for everybody.
Yeah, of course.
All right, then I will stop talking for real, except to say thank you. We made it. We made it out alive. Thank you for your time. Thank you for your energy. Thank you for your efforts. I hope you get something out of it. And if you're feeling overwhelmed right now, that's okay. I hope that you have enough material to come back to someday if you ever need to do this stuff for real. And to that end, you have all earned the right to bother me. Okay? You're allowed to send me emails, even if you're not in this class anymore, if you need help with this stuff in the future. I'm more than happy to direct you to resources or try to help you troubleshoot things, because I want you to use this stuff in your lives. Otherwise, it'll just, go to waste. So let me know if you need help with homework. Office hours are next week by myself only. I'll be on email. And otherwise, I hope you have a great summer and that I get to see you in the fall. Okay. Yeah, go home early. Woohoo!